Welcome to episode 2 of this algebraic series. Today we'll be starting with algebraic simplification, addition and subtraction in algebraic expression. Now we'll start with a question. This question we're going to solve first. We're going to analyze it. From the analysis, you understand how to add and subtract in algebra. You have a question that goes like this: 2x plus 4y minus 3x plus 5y. We want to solve this question. Now, how do we solve this question? The first thing you need to know is that you must add like terms. When we talk about like terms in algebra, let's write it out. Like terms. When we talk about like terms in algebra, we're talking about those terms that have the same letters. They have the same letters. So these 2x and minus 3x have the same letters. So we can say that they are what? Like terms. Now 4y and plus 5y can also be called what? Like terms. This is what we call like terms in algebra, when they have the same letters. And the example of like terms are this. Let's say for instance you have 2xy and 2x squared. Are they like terms? They are not like terms. Now why they say they are not like terms? If you look very well, you have xy here, you have x squared here. First of all, in the x, this x has a degree of 1, but this one has a degree of 2. So it has already disqualified it from the like terms of x. And again, the first one has xy, that's another alphabet letter there, y. And this one does not have y. So because of that, they are not like terms. So even if you have 2x and 3x squared, they are still not like 10, because in this case now, we will now be looking at the power in front of what? The power in the letters. This one has x raised to power 1. It's not written there, but it's actually there. And this one has raised to power 2. So because of that, they are not like terms. So please note this. But know that when you have 4xy and 5yx, that they are what? Like terms. Why are they like terms? Because the xy you have here is what you have here, yx. Yx can be written as xy also. You can write this as xy also. So now having the same letter as 4xy also. So these are like terms you need to know. When you know this very well, you won't have problem knowing when you have like terms or not. That's the first thing you need to note. The second thing you need to note here is when adding algebraic expressions, what you add or subtract is the coefficients. Now what do I mean by that? Remember our question: 2x plus 4y minus 3x plus 5y. Now you don't add the alphabet x and y, or the x. You don't add the alphabet. You just add the numbers in front of it. That's what you call the coefficient. So in this case, this 2x and minus 3x, what I will be adding is minus 3x and the 2. And now that will take us back to the last episode where I explained how to add and subtract numbers. Where I told you that when you have the same sign, what do? You add. You have different sign, you subtract. And the answer will carry the sign of the bigger number. So let's quickly apply it here. So first of all, we are going to collect like terms of this question. Collecting like terms, remember what I told in the last episode, that you move with the sign in the terms. So you have 2x. I will now bring minus 3x, because this minus 3x is a similar term to 2x. Then I have plus 4y and plus 5y. Now we have collected like terms. The next thing we're going to do is to add the numbers in front of it, which is the coefficients. So I'll ask myself, for this one, I'll have 2 minus 3. That's plus 2 minus 3. What will it give us? They are different signs, so I subtract 1. Then the bigger number is 3. It has minus. I'll put the minus. So I have minus 1x. Remember that this can be written as minus 1x or minus x. They are the same thing. Then the second one, we have plus 4 and plus 5. In plus 4 and plus 5, they are the same signs, so we add. 4 plus 5 is what? Is 9. The bigger number has plus, so we put the plus. So you have minus x plus what? 9y. At this point, some students will be tempted to solve more by saying minus x plus 9y is what? Now this is my final answer because x and y are not like terms. So this is what you get as your answer. Now we're going to solve more questions under this so that you will enjoy it more. Let's solve this question. 6p minus 2q plus 4r minus 2p plus 3q plus 6r. Now, like I said before, the first thing we're going to do quickly is to collect like terms. We have 6p, and that like term here is minus 2p, so we bring it together. We have minus 2q, and we have plus 3q. We have plus 4r, and we have plus 6r. If you have done that, then that's good. The next thing we do is to add or subtract the numbers. So 6 minus 2 is what? We have 4p. Now we have minus 2 plus 3 is what? We have plus what? Q. Remember what I said, minus 2 plus 3. They are different signs. You subtract to have 1. 3 has plus, so you put plus there because it's a bigger number. Plus 4 plus 6 will give us plus 10r. So this becomes our answer. Why? P, Q, and R are not like terms. So this becomes your answer. Good. You can as well try out this question. 4x plus 2y minus 3x plus 7y. Alright, let's solve it. So we collect like terms. 4x minus 3x plus 2y plus 7y. 4 minus 3 is what? You have x. Plus 2y plus 7y will give us what? Plus 9y. This becomes your answer. Remember, they are not like terms, so you don't add it, two of them together. Alright, let's solve this question that looks as if it is complex, but then it's not complex. And what's the question? You have 5a square b minus 2ba square plus ab square minus 4b square a. I will use this to summarize for this episode. Now, is this question actually difficult? It's not difficult. Forget about what they are trying to write in this. Remember what I told you. A, B, and B, A are the same thing. All you need to do is just to rearrange this A, B to this B, A to become A, B. Good. With that, you can be able to solve this question. Now, I have A square B. Just look at the ones that have the square on top of it. In this place, I have square in A. In the next question here, I have square in the word A. And I have B. So, which means this term, and this term here, they both have the same alphabet, the same letter. The only thing different is that in this second one, B came first. So all I need to do is to rearrange this to put it the best way I'm meant to put it. So I'll have 5a square b and minus 2a square b. Good. In the second one, I have ab square. In this one around, the square is now in the b, and the same thing happened in 4b square a. just that b square came first. I will have to rearrange it to have ab square. So which means this will now become plus ab square minus 4ab square. Good. Now it means that this and this are like terms. And what do I add? I add the numbers in front of it. So 5 minus 2 is what? You have 3a square b. Coming to this, I have ab square. So what number is in front of it? Don't forget that in the last episode we agreed that when you have a term like this, that it has 1 in front of it. So it means that there's 1 here that is not shown. So this 1 plus, that's 1 minus 4. 1 minus 4, what will it give you? We subtract because automatically there's a plus here. So there are different signs, so we subtract. We have 3 and 4 is a bigger number. The sign there is minus. I put it here. So you have minus 3ab square. At this point, you'll be tempted to do what? To subtract more or to say that the answer is 0. But look at it very well. I have a square b. I have ab square. You may say, yeah, they have the same letters, so why not subtract the two of them? Good. I talked about when they have different degrees. In this place, the a has degree 2, this a has 1. They are not the same thing. The b here has 1, this b has 2. They are not the same thing. So because of that, I will leave this as my answer because they are not like terms. That's very good. Now, to summarize for this episode, I would like you to solve this question. I will continue with in our episode 3. So write it down and solve it and look out for episode 3 for the solutions. Alright, solve it and look out for episode 3 for the solutions and more things you need to know in algebra. Thank you.